educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on fluid statics. In our last lesson, you learned about one basic rule of fluid statics. This rule is called Pascal's law. You learned how the principles of Pascal's law are applied in hydraulic systems. Today, we will look at another basic rule of fluid statics called Archimedes' principle. We have a lot of material to cover today, so if you are ready, students, let us begin the lesson. Archimedes' principle states that any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. Most people think of a fluid as a liquid, but the scientific definition of a fluid includes either a liquid or a gas. The buoyant force referred to in Archimedes' principle is the upward force on an object immersed in or floating on a fluid. If the object weighs less than the buoyant force, it will float in the liquid immersing itself partially. If it weighs more, it will sink. This is a fairly simple principle, but it is an important one because it tells us whether or not an object will float. Because the buoyant force equals the weight of the fluid displaced, an object must displace a greater weight of fluid than its own weight in order to float. That means, in order to float, an object must have a density less than the density of the fluid. If the object's density is greater than that of the fluid, it will sink. Remember, students, that density is found by the ratio of mass divided by volume. In this video, we see a student dissolving a white substance into a clear liquid. The white substance is sodium chloride, or table salt. The clear liquid is water. The student ensures that the salt is completely dissolved in the water. It is necessary to make sure that the solution is of uniform density. He places an egg in this solution. It floats. When a similar egg is placed into a jug of plain water, it immediately sinks. Students, please move into groups of 3 or 4. Using what you have already learned about buoyancy and density, can you explain why the egg floats in one solution and not in another? Please take a few minutes to discuss your ideas.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to answer the question? You have learned that in order to float, an object must have a density less than the density of the fluid. Since the student in the video did not change the density of the object, he must have changed the density of the fluid by adding other substance to it. In fact, adding salt increased the density of the water to a point where it became more dense than the egg. If you have ever swum in the ocean, you may have noticed that you were able to float more easily in salt water than in fresh water. That is because salt water is more dense than fresh water. A swimmer, therefore, displaces a greater weight of salt water than fresh water and is more buoyant. Ships, even those made of metal, float because they have enough empty space inside their hull that their total average density is less than the density of water. An iceberg floats because ice is less dense than the water it floats in. Helium balloons fly because their average density is less than the density of the air around them. A sinker is able to float when it is connected to larger volume of floating substance. In all these cases, the fluid, water or air, creates an upward buoyant force equal to the weight of the fluid displaced. The upward buoyant force is greater than the downward gravitational force. Students, you can see why it would be important to know the density of various fluids. To make it easier, you can use an instrument called a hydrometer. A hydrometer is an instrument used to measure the relative density of a liquid compared to the density of water. A hydrometer is usually made of glass and consists of a cylindrical stem and a bulb weighted with mercury or lead to make it float upright. Liquid is poured into a tall container, and the hydrometer is gently lowered into the liquid until it floats freely. Hydrometers often contain a scale inside the stem, so that the relative density can be read directly. The point at which the surface of the liquid touches the stem of the hydrometer is its relative density. Imagine, students, that you have 3 containers. The first one contains gasoline. The second one contains water, and the third container is full of a brine solution. Let us say that water has a hydrometer measurement of 1. If you were to put a hydrometer in each container, can you predict the results?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. What were your predictions? If the relative density of water is measured as 1, then the relative density of the brine solution will be greater than 1. We know that a salt solution has a greater density than water, and we expect that the hydrometer will float. You have probably seen gasoline or oil floating on top of water. Gasoline is less dense than water, so it will have a hydrometer measurement of less than 1. We can expect that the hydrometer will sink in the container of gasoline. Hydrometer moves deeper in lighter liquid than denser liquid. Today, you have learned about Archimedes' principle and how the density of an object affects its ability to float. In our next lesson, we will look at atmospheric pressure and the pressure of gases in a contained area. Until next time, thank you, teacher. Thank you, students.